In the previous video lecture, I showed how to collect the data for diameter and circumference of different kinds of circular objects. In this video, I'm going to show how to plot a graph of circumference versus diameter for the data that you collected in order to find the value of pi. So here is the data that I have collected, and I need to first enter all this data in an Excel file. So on the first column I have the circular object numbers. So I have numbered the circular objects as 1 through 8. You may have more than 8 circular objects, but I used only 8 circular objects. And here I have the diameter of the circular object, and here I have circumference. Okay, so in order to plot circumference versus diameter, I need to select these two columns and then go to insert, and here I will choose this scatter plot. Okay, so there are a bunch of options here, but I want the scatter plot without the data connectors. So if you choose this one, you will get a graph with the data connector, but I don't want the data connector, so I'll just plot that. So that's what I get. And then I need to label the graph. So we need to say what this y-axis is and what this x-axis is. So to label the graph and to give the appropriate title, I need to go to chart design and then go to chart, add chart element, and then primary horizontal. So on primary horizontal I have diameter, so I need to write here diameter and then put parenthesis, and here I'm using the unit centimeters, so I need to put centimeters here. And then for the vertical axis, I need to label that as this vertical axis as circumference, so write circumference, and then again this is in unit of centimeters, so I need to put cm for that. So that's the graph. Now I also need to change this title. Title is circumference versus diameter, so I need to write circumference versus diameter, and then I need to use the linear trend line to find the slope of this graph. So in order to fit this with a straight line, click on one of the data points, right click, and then add trend line, and then you can check this box with display equation on the chart, and then you have this equation. Okay, so in this equation, this is a kind of a straight line equation, y equals mx plus c, where this number is the slope. So our slope is 3.245. okay, and that's the value of pi given by this equation. So you can actually enlarge this slightly bigger, and then you can also change the font size. Go to home, and then maybe the font size, make the font size 12, or even bigger if you want. You can make it 14, and then maybe you can make it a bit nicer by moving this slightly away from the numbers, this one slightly down, and that's that equation. So this is the graph you will need to submit along with the lab sheet. Okay, so what you can do is you can save this graph, or you can maybe copy this and paste on a Word file and convert that to PDF, or the easiest way is just to take the snapshot of this graph. So I'm going to take the snapshot of this graph, and you can just submit that snapshot. Okay, so just take the snapshot like this, so you can submit this on Gradescope. Okay, I'll show you how to submit this on Gradescope in a second. But before that, let's go to the lab sheet. Okay, so I want to show you what kinds of things you need to write on the lab sheet. So you can get the lab sheet in Blackboard under week 1 lab. So you can open that and you can open lab 1 measurement. That's the lab sheet you need to submit. All right, so it's open on the browser, but I want to write over it. So you can either print this out, or if you want to write on this, you can save that somewhere and open separately, not on the browser. So I'm going to save it on download, and see, here is my lab 1 sheet. I expect you to read all these things. Okay, introduction and procedure. This will tell you what's the theory behind this lab and what are the steps you need to take in order to collect the data and set up the experiment. When you do the experiment, you will get the data. You will be entering the data here. So here you will write the name of the circular objects that you used, and this is the diameter, that's the circumference, and you have here plus and minus, plus and minus. So here you will put the smallest division of your measuring device. If you're using a ruler, the smallest division would be 0.01 centimeters or 1 millimeter. So you can put here 0.01 centimeters. Okay, that's the uncertainty of the measurement. So here there are a bunch of questions you need to answer. The first question is asking you to identify dependent and independent variables in this data. So dependent variable is the quantity that depends on the other quantity. So for example, if you have two variables such as number of hours you work versus the amount of money you earn, the amount of money you earn would be dependent variable and the number of hours you work would be independent variable. In this experiment, you need to determine which one is dependent and which one is independent variable. So think about this in this way. So if you increase the diameter, what it does to the circumference, right? If you want to increase the circumference, what you need to do with the diameter. So that tells you which one is dependent and which one is independent variable. The second one is what happens to the circumference when the diameter is doubled, reduced to 1/2. So in order to answer this question, you will need to see the data. Okay, so for example, you see the data with the diameter of 1 centimeters that has a particular circumference, and if you look at the object that has about 2 centimeters, double the diameter of the previous one, see what happens to the circumference. What types of relationship exist between circumference and diameter? So you need to look at your data or the graph to see what kind of relationship that is. So in a mathematics, we can have linear relationship, like when you double one quantity, the other quantity also doubles. That's kind of linear relationship. Or we can have quadratic, or we can have exponential. So you can see this graph and tell what kind of relationship you have, whether it's a linear or quadratic or exponential or inverse. Okay, those kinds of things. Plot two circumference versus diameter graphs, one for your own data and one for the general class. So because this is in-home lab, so we don't need to worry about the general class data, so you will only plot one graph. Can you fit the data with a straight line? So you can just answer that based on what you did with this graph. So you see that it's perfectly fitting the data. This line is perfectly fitting the data. Now you need to write the equation, this equation that you got here, in terms of physical variable. Okay, this is a mathematical equation. You want to write this in physical variable. So here our y-axis is circumference. You can write that as c, and this is a number. And then x is the diameter. You can write that as a diameter. So you can write this equation as a physical equation. So c equals some number times d minus that. Okay, that's what this question is asking. The actual equation that relates c and d is that c equals pi d. That means if you compare these two equations, 3 and 4, then this pi would be given by this number. right? So here this is pi, and we also have some intercept here, but in the actual equation there is no intercept. Right here there's nothing. That means we have small error involved in the experiment, and it's always possible to get some error in the experiment. There is always some kind of uncertainty in these kinds of experiments. Now there are some post-lab questions. You need to answer those questions. What are some of the possible sources of error in your experiment? So you need to say there may be some error with the measuring device, right? All those kinds of things. You might not have measured the values correctly, so you need to write all the possible sources of errors, and then what would you do to minimize those errors? You answer those questions. Okay, so once you complete that, now you need to submit this on Gradescope. Let me show you how you do that on the Gradescope. So if you go to the Blackboard, you will see on this side there's a Gradescope submission. So you click that. It will take you to the Gradescope page. If it doesn't take you to that page automatically, you can just click that, launch. So that's the page, and here you will see the link. I haven't posted the link yet, so you will see the link, and once you click that link, it will instruct you to upload your files. Okay, so once you upload that, click all the pages that you submit. If you click only one page, it will submit only the page that you click. So that means you need to check all the pages that you want to submit. So if you have any question, please email me. I will be more than happy to answer your questions. Good luck.